Good morning, everybody. It is great to be here with all of you. I have a chance to talk about some really exciting things we've been up to and working on in the graphics space. So the DirectX team has a long history of graphics innovation. Starting in 1995, we've been at it for almost 2 decades. For example, in 1998, DirectX 6 added multi-textures, texture compression, dependent texture reads, etc., that enabled a whole new slew of rendering techniques in real time. With DirectX 8, we introduced programmable GPUs with vertex and pixel shaders. DirectX 10 made life easier with a whole new clean API and a thoroughly standardized hardware spec that minimized hardware variances. And on and on. So here you have some examples of how much progress we made from Halo 1 to Halo 4. We have a continuous collaboration with the hardware vendors on drivers, silicon, future GPU technologies, helping silicon innovation. We also work with developers of top game engines, creators of the latest graphics rendering techniques, and top performance experts in the industry. Finally, we heavily use our own staff for everything that we care about, from the entire OS UI, the compositor, Internet Explorer, Office, and so on. All of this is built on top of DirectX. All of this gives us a really great way to tune and validate the DirectX stack for a broad range of use scenarios and truly convince ourselves that this works. One of the things that's been true for a very long time is the aggressive growth in GPU performance. Graphics is an embarrassingly parallel problem and has plenty of headroom to consume silicon area and cycles. CPUs won't be growing in perf nearly as fast. For one thing, single-threaded CPU performance is not growing as fast. It's growing slowly. The only real way to get better CPU performance is to do effective multi-threading. But even that can only get you so far. CPU core counts are not increasing aggressively. This imbalance in growth rates really raises an important challenge for us. How do we effectively exploit the GPU? How do we keep it fed with work while still using the CPU for gameplay, AI, and everything else? We could keep cranking up the resolutions. We can increase rendering quality. And we can increase the amount of things we can draw. The first one is easy. The second one is hard, but the various versions of Direct 3D have helped raise the bar in rendering quality and features. Up until now, though, the third one has been a challenge. As game developers, you understand these trends very well, as you run into this in your latest and greatest games and game engines. You asked us to eliminate any overhead between your app and the GPU. You want more controls so your games are consistent and predictable. And you want a console-like API. But you want it across PCs, across a broad set of hardware. Oh, and by the way, you want us to not stop advancing the state of the art of the rendering features. The engineers at Microsoft and the GPU manufacturers have been noodling at this for some time. And we came up with DirectX 12. This is no dot release. Today, I'm going to focus on one of the most important parts of DirectX 12, and that is Direct 3D 12. So what is Direct 3D 12? Well, it's even more direct. Of course it is faster, a lot faster. It will enable far richer scenes with more objects and advanced effects that fully exploit the GPU. And we designed it for the full spectrum of computing products, from the lowest end, lowest cost smartphones to game consoles and the highest end PC graphics cards. We want to have the fastest way to exploit the GPU. With DirectX 12, Xbox One's games will see improved performance, and we're going to bring the same API to all Microsoft platforms. Direct 3D has always been the most consistent and conforming 3D API across a large set of GPUs from many different companies. We take pride in obsessively testing and validating the API and its drivers. You should expect the same from DirectX 12. And we know an API is only as good as the tools you have to use it. And so, the day the API is available to developers, we will have great tools for it. So let me share some of the improvements we have made. DirectX 12 represents a big shift in the shape of 3D APIs. When we first started doing Direct 3D, we had a retain mode API and an immediate mode API. The latter was supposed to be the low-level API. Well, with Direct 3D 12, it is the first version to go much lower. This is the beginning of a new era in graphics APIs. In providing an API that works across a diverse set of hardware architectures, current graphics APIs have always had a small overhead mapping API to the specific GPU. At Microsoft, we spend a lot of time understanding modern GPU intimately, poring over their driver source code and hardware specs to find ways to efficiently map the API of DirectX 12 to the hardware. Graphics-intensive apps use a lot of graphics resources, and quickly getting all your textures and vertex buffers and constants and so on to the GPU and update them on the fly requires a lot of focus on improving resource management. And I'm going to talk a bit about a few new rendering features. But before I get deeper into the technology of DirectX 12, let me show you some very early results with our prototypes. What we have here is we have ported the latest version of 3D Mark. So what I'm running here is the latest version of 3D Mark running on DirectX 11. So it's just starting up now. So what's going on here is 3D Mark is trying to use all the CPU cores available using D311. But as you can see, what we've done is we've hacked up 3D Mark over here to show you how the various 4 cores are being utilized. This is running on an Intel Core i7 4770K. And as you can see here, 1 core is doing most of the work. The other 3 cores are trying to help, but it's not doing as much. So we decided to try and port this to DirectX 12. And what you will see is we got a couple of key perf improvements as we move this to DirectX 12. First, you will see that the overall CPU utilization has dropped by 50%. But what's more is that the work that is being done on the CPU is very evenly spread across all 4 cores. And so the total headroom available on the CPU, as you can see by the dashes, is significant. So this will make it a little bit easier to see. The top right chart is D311 and the bottom right chart is D312. So you can see from the table, the longest thread in this was thread 0, and we have managed to reduce the overall time on the CPU from about 7.9 milliseconds to 3.8 or 9 milliseconds, which is halving the time on the CPU. And you're getting near perfect scaling across all 4 cores in D312. We see a reduction in graphics of almost 5x on the time spent on the CPU. This is a pretty amazing improvement on existing optimized D311 code on existing hardware, just by shifting to the latest API. To show you how we get these improvements, I'm going to give a quick technical overview of the API. We reduce the overhead of changing rendering state like shaders and blend modes and rasterizer state, etc., by grouping the entire pipeline state into what we call pipeline state objects. These objects can be mapped very efficiently to the actual GPU hardware. We have also enabled reuse of rendering commands frame over frame by putting them into a new construct called bundles. We notice that most apps and games have a lot of similarity of what they draw from one frame to the other, and we have exploited that to come up with this new API construct. We've also solved multi-threaded scalability. Direct3D12 has new command lists that can be created and used across threads and get near perfect scaling. They can be created and used completely asynchronously. Changing textures and other resources fast enough has also been a challenge in past. We have a new resource binding model that makes changing what resources are bound to the CPU much more faster. It also allows you to bind a large array of resources and then let the GPU decide which one it wants to use without any CPU overhead. Finally, we allow you to cache the GPU compiled and optimized pipeline state and all the shaders so that you never have any compilation happening in the API or in the drivers in the middle of your gameplay. Direct3D12 allows the apps to control graphics memory using this new heap features that allows you to amortize resource create and destroy costs, and also makes reallocation and reuse of memory extremely fast. We will also give the application more control over placement of resources within these heaps. Resource creates and destroys and uploads are completely free-threaded now, helping multi-thread scalability. We will also allow access to swizzled resources to avoid any intermediates or copies. And we have added more ways to compress resources with ASTC and JPEG image decompression support in hardware. One of the underlying trend across most of these features is the API is now much lower level. The application now tracks the GPU pipeline status, not the API and not the driver. Applications also explicitly control resource state transitions, like when a resource is used as a render target and then when it's used as a texture, or vice versa. The app is also now responsible for avoiding pipeline stalls by doing resource renaming as appropriate and necessary. The API and the driver will not add overhead trying to do this for you automatically. The point here is that there will be less API and driver tracking. Since the app is in control, it will have much more predictability. And only you as the developer know what your intent and what you intend to do. So there's no use for the API or the driver to guess. This is going to be an advanced API, targeted towards the smartest game developers. But it is going to give you unprecedented performance. All these improvements alone make DirectX 3.12 an awesome API by reducing CPU overhead and giving you low-level control. But we wanted to do more. We are also planning to advance the state of rendering features. In DirectX 3D parlance, that means we're adding feature level 12. We have a bunch of things we are working on, but I'm just going to highlight a couple of examples for now. This is by far not the complete list. With pixel-ordered UAV accesses, we are bringing some order to the supposedly unordered access views. This helps make sophisticated translucency algorithms possible and also do more programmable blend algorithms in the app. With conservative rasterization, you can have the GPU render in a way that makes it easier to depth cull complex things that are not visible, and also do fast collision detection algorithms right on the GPU. We are constantly working with the GPU vendors to find new ways the GPU can be enabled to do the best rendering techniques and algorithms with great quality and performance. So how do we know we are on the right track? We wanted an API that would perform as intended and wanted to be sure that it has console-like efficiency. So we worked closely with our friends from Turn 10 Studios who have been spending time with us on DirectX 3.12 right from the start. From the makers of Forza 5, please welcome Chris Tector. Thank you, Chris.
Thanks. Hi, everyone. Thanks, Anuj. So at Turn 10, we're strictly a console developer, and we're used to going as close to the metal as we can. And this is great because D3D12 is a low-level access API that gives us features that target direct GPU execution, which is exactly what we want. Now, this whole endeavor started as discussions kind of last fall, and it shifted into a porting effort earlier this year as the Alpha API became available. But long before that, before we had dev kits on the Xbox One, we had ported to PC D3D11, and we found that we had major CPU overhead issues, both in D3D and in the driver layer. But what we're showing you today is a tech demo of a port to D3D12 on the PC. And although it's a bit rough around the edges because it's an early API, it already represents some great gains, and we're very excited. Now, overall, this took 4 man-months to port our entire rendering engine from an Xbox D3D11X version to the PC and D3D12. But largely that's because, in a lot of ways, as game developers, we're already used to some of the features where we're used to managing our own resource memory, or some of the features actually came from Xbox One to begin with. Bundles started out as draw bundles on Xbox One. And then for other features that were new to D3D12, they're actually the way that we deal with our data in our game. So pipeline state objects actually track combinations of shaders and the state as a unit, and that's exactly what we do in our material systems. And then tracking resources as groups in resource tables is exactly what we do so that we're ready to set that complex set of resources on the device immediately before a draw. But let's see a demo. So this is Forza 5 running on D3D12. I'm just going to unpause the physics and then let the AI drive for me. Oops. And that way I can go over some of the extra features. Don't worry, it's a P1, it'll catch up. So one of the biggest features that we're excited about to see that it had come over to D3D12 is bundles. And not only is it because it's a free-threaded recording model, but what the new command lists and bundles on D3D12 gives us are command streams that are directly executed by the GPU. There's no more resubmission happening in the driver on the CPU, so they're very low cost for the CPU, and we can get all that performance back. But one of the best features about draw bundles, and one that we use very heavily on Xbox One, is the inheritance. And what that means is that they can have resources set on the device that they can refer to, even though those resources weren't available at recording time. Now, this is a major feature for us because what it'll let us do is take any of these trees, are all probably several different bundles, but they're all common models that have been recorded to bundles. And we can set different constants, so we can instance them around the scene, and constants to drive material parameters, and also different textures. And so we can completely get the variance we want across the scene and the density, but we've amortized the recording cost of the bundles, which is extremely important for us. So the next big feature that for us is having the resource lifetime. Now, not only can we track the resource memory ourselves now, and that's important for size reasons, but we no longer have D3D tracking that lifetime. And so that means there's no more expensive reference counting happening at execute or draw times. It's all up to us, and that's the way that we like it. And importantly, as Anuj pointed out, resource creation and destruction is now free-threaded. In D3D11, we were seeing major hitching and CPU overhead issues because on background threads, we're constantly streaming models as we drive around the track. And as we do that, we would create the resources that we needed for the models, and that meant that we would see hitches on the primary rendering thread. And then finally, an important feature for us that's new to D3D12, newer than what we have on Xbox One, is the resource tables. And what that lets us do is create a complex set of resources, like I said, all the constants and textures we need for a particular bundle, and we can set that entire set with a single command. And so a single command to set the full resource set and a single command to set the bundle gives us the maximum efficiency that we want. So overall, we're very excited to see console-style development coming to PC with D3D12, and we're especially excited that these features are going to come back to Xbox One.
Thank you, Chris. Wow, that looks amazing. Awesome. All right. So we have a new low-level API that works well across different GPU architectures. So what kind of GPUs can support DirectX 12? To answer that question, I thought I'd have some of the GPU hardware leaders come and share their thoughts on DirectX 12. Each of these companies has worked really closely with us to help shape and design DirectX 12. I'd like to start with AMD, who share our vision of low-level APIs. Ladies and gentlemen, please welcome Corporate Vice President of Visual Computing, Raja Koduri.
Thank you, Anuj. Let me jump right in. Anuj, set the whole thing up really, really well, and I just want to, take just a very few minutes to share our excitement in participating in DirectX 12. AMD and Microsoft had, really deep, long history of partnership on GPU APIs and development. In fact, many of our architectures have been heavily influenced by DirectX architecture, or hardware architectures, and vice versa. The DirectX API has been influenced by some of the hardware architecture advancements we have made. And you can see the list of, the last several years of advancements, all the way, dating back to R100 in late 90s to DirectX 11.1 and Graphics Core Next, which is in all the modern game consoles. Now, what's interesting is, these conversations and, we have a very tight collaboration. And, there is tension, right? We are trying to push hardware forward. Microsoft is trying to push their platform forward. And we have smart guys on both sides and smart guys from, some of our competitors all engaged and trying to push, the thing forward. And there is tension, good constructive tension. But DX12 is one API in my, 15, 16 years of being engaged with Microsoft is where we had the least tension. We shared common goals, common problems to be solved, and the results are really great. And why? And why is that excitement? It's a low overhead API. Anuj covered all of these issues. It enables multi-core to be utilized much better. So giving access to a wide range of hardware for existing content. But the key thing is that DX12 benefits existing user base, right? People who already have our current GCN hardware, our current CPUs, they get benefit of this API on day one. And it's not a small benefit, as Anuj and our game developer friends have demonstrated. It's a huge benefit, right? It's like getting 4 generations of hardware ahead with the release of this API. This is huge. At the end of the day, our focus is how do we make our game developer friends' life better, and how do we make our users be thrilled with the things that we ship. And DX12 has both those ingredients. And there's a lot of technical detail that Anuj covered, and there will be a lot more technical detail that will be coming. And we have a talk, Dave Oldcorn from AMD will be talking later today on details of D3D and our platform. And like I said, we have worked very, very closely on this, and we are thrilled to see this get announced. And DirectX architecture is hugely important for us and in the industry, right? It won't be an exaggeration to say that no 3D pixel that is rendered today is not influenced by DirectX architecture. Every pixel that's rendered today on all platforms has had huge influence from the DirectX specification. So anyway, thanks Microsoft and Anuj for providing us this opportunity to be here with you. Thank you.
Thank you, Raja. That's awesome. So next up, from Intel, the company that sells the most PC GPUs, please welcome Vice President of Platform Engineering Group, Eric Menzer.
Three decades, I think. And through that relationship, we've brought some really incredible technologies that have just changed the way people have lived, work, and play around the world. And probably over the last 15 years, we've worked really closely with Microsoft on graphics. But I've really seen a change in our relationship, certainly over the last several years, as we made a major change in our graphics strategy to move graphics from lagging edge process technology in the chipset up into the processor, the SoC, and tightly couple that on the world's best process technology. And that created real breakthroughs. And we, over the last year, have been working very closely on how to really evolve our hardware, how to evolve our drivers, along with the APIs. And I've just seen this in the industry, being with Intel about 30 years. When you get a bunch of smart people together that are really passionate with a common goal, there's just some incredible things that can come out. And I've learned to spot, when you see those real inflection points, and this is one of them. This is absolutely, I think, one of the most significant jumps in technology in a long, long time. And that means it's good for game developers. It's good for games. In the end, I'm personally looking forward to some of the great games that are going to be out there and seeing the user experiences that are just going to, I think, wow people. I think it's important because it does give this level of control to the technical developers. And when the news showed you what was happening with the microprocessor, where we were making much more efficient use of that processor, let me explain why that's so important. It's much more important in these power-constrained envelopes. When you only have a watt, when you only have 5 watts, when you only have 10 watts to share between memory, graphics, and processor, if you can actually make much more efficient use of that processor, that graphics controller can turbo up, take advantage of that, and we see a huge scaling in graphics performance as you give the graphics an extra watt, especially in these power-constrained envelopes. So, we've been working very closely with them in developing this API. We think that it's very important especially for modern integrated designs like the Core i7 that you're showing here. And we also think it's really important to have standards. Not just standards, but standards that we can bring into the market in very high volume, because I think that's what most developers care about, is what's going to be the footprint. And I can tell you that we're committed to bringing this to absolutely to high volume. We're supporting it on our 4th generation core processors. We'll be there at launch time. And I think this is going to drive very quickly into the market, because the user experiences that's going to come out as a result of it, I think, are going to shock people. So Intel, full support, and we're very pleased to work with Microsoft on this. Thanks.
All right. Thank you, Eric. So, next up, from the heavy hitters in the PC gaming space, Senior Vice President of Content and Technology, Tony Tomasi. Thank you, Tony.
Clicker. Good morning. We're pretty psyched. We're really happy to be here. We've been working with Microsoft for a very long time on graphics APIs, pretty much since the dawn of DirectX. And really, we've been working with Microsoft on D3D12 and DirectX 12 since its inception as well. From a philosophy perspective, graphics APIs are, of course, very important, and the efficiency of the API is extremely important. We've been committed to delivering the highest performance standards-based graphics drivers since the beginning, actually, at NVIDIA. The efficiency is super important, and you can drive efficiency through existing D3D11 drivers, and we've been working really hard there. But of course, we completely understand the value of really low-level access, console-like access and control, and that's what the engine vendors and the creators want. So we've been working with Microsoft to build an API that's an industry-standard API that enables something like that. We think that should be done through standards, as was mentioned before, so that there's broad installed base, broad penetration, so that when D3D12 ships, instantly the majority of the market can flip over and you can have all the benefits of DX12 capability on that installed base without having to fragment it or build 17 different renderers for 17 different platforms. So that's really kind of core to our philosophy. On the API itself, of course, we've been working really hard on D3D11. We're right there with Microsoft in D312. I'll give you a little hint on kind of our status there. And we're going to commit to support DX12 on every operating system that Microsoft will ship it on, and literally every processor architecture that we can support it on, which should be Fermi, Kepler, Maxwell, and Forward. And I'll break that down in terms of some data and what that means. But we are fully behind DX12. We think it's going to be awesome, and we're going to do everything we can to make it a success. You know, we've talked about this a little bit, so I won't spend too much time on it, but you know, we're excited for a bunch of things. The submission reduction, the cost in submissions for API is going to allow richer content on a broader range of platforms. It's going to reduce power. It's going to embrace all the latest GPU architectures. You got a little teaser for some of the new features that are coming in the API. One of the other big advances, of course, is that it's highly scalable, not only in terms of the control that it's going to allow for multi-core CPU, but scalable across really broad ranges of GPUs as well. And providing more control to the developer will allow scalability actually for how they utilize the GPU themselves, more explicit control of memory, more explicit control of resources. All of that is super exciting stuff, and for the developers that want to get down deep and they want to do their own resource management and they want to manage their own buffers and their own allocations, this is going to be an API that's going to be super exciting for them. From our commitment perspective, this is just taking data directly off of Steam, which we're kind of using as a proxy for the game installed base. You look at the DX11 installed base, there's about 70% or so of the installed base is DX11 hardware out there. Roughly 25%, 10 and 3% or so, 5%, 9 prior to that. NVIDIA represents about 55% of that installed base. And all of it, we're going to bring all of our DX11 hardware capability and offer DX12 drivers for that. So from day one, really about 40% of the installed base, and that's today, just from NVIDIA, is going to be ready for DX12. And we would encourage all the other GPU vendors to deliver the same kind of broad base so that you guys, creating great games, can have a huge market for them. So we not only are we going to deliver this at day one for DX12, we're going to deliver this with super high performance. So Anuj alluded to this a little bit earlier, but we're seeing really tremendous gains. For simple things like render state and blend state changes, you're getting 3x reductions. One of the other great advantages by the control you're getting here is you get much more efficient utilization across multiple cores, which can, again, reduce the overhead by integer multiples. This is a big deal. We're going to go from, hundreds of thousands to millions to potentially tens or maybe hundreds of millions of draws a second, really kind of unbounding the API to really allow a great amount of creativity. We're right there. In fact, we've delivered DX12 drivers to developers already. The tech demo that you saw running was running on NVIDIA's DX12 drivers, on NVIDIA's hardware. So we are as enthusiastic and supportive and engaged on DX12 as I think anyone on the planet. We can't wait for it to ship, and we can't wait to see what you guys do with it. So again, thanks for having us here. Thank you to Microsoft for building something awesome, and we can't wait to see what you guys do. Oh, sorry. I forgot. Yeah. And he was just like, no, the quote. So you might have heard of this other company called Epic. They make a little piece of software called Unreal Engine and some really great games, the Gears of War franchise, for example. We've, of course, had a great partnership with Epic over the years. Tim is a brilliant guy. And Epic is enthusiastically behind DX12 too, because really what it gives them is what they want. They want that control over the hardware they want, but they want it through an industry standard. So I'll just read the quote. This is from Tim. Feel free to, if you track him down in the booth, he's here, and chat with about it. But they'll be working closely with NVIDIA and Microsoft to create a world-class implementation of DX12 and UE4. DirectX 12 is a great step forward, exposing low-level hardware functionality through an industry-standard API to give developers more control and efficiency than ever before. That pretty much sums up exactly the spirit and the soul of DX12. And of course, I think you've already got one of the most important game engine developers announcing their intent to support it and their excitement for it. So that really kind of sums it up. We think DX12 is going to be awesome. Developers hopefully will find it awesome, and we're going to do everything we can to make it a success. So thanks, everyone.
Thank you, Tony. And last but not the least, highlighting the breadth of GPU architectures we want to cover. From the giant in the mobile space, please welcome Vice President of Engineering at Qualcomm, Eric Demers.
Thanks, Anuj. Certainly not least. I actually thought I would introduce my first slide to address sort of an elephant that I see in the room. Is like, first question I got this week was, why is your logo associated with DX12? What is Qualcomm doing here? I'll be honest with you, I can't quote 3 decades. Personally, I can, but Qualcomm has been working and been a partner with Microsoft on mobile graphics, actually since there has been mobile graphics, which is a really good statement from our perspective. We've been partners not only on graphics, but on all the key mobile APIs and technologies that are required to give a great mobile user experience. It's a commitment both on the technology side as well as on the product side. We've put skin in the game. We illustrate here just for every large launch, for every key initiative on the Microsoft mobile platform, we've been there with products, and we've been pushing and growing that base in partnership with Microsoft. And even today, if we look at most of the Windows Phone are powered by our Snapdragon processors, and 800, which is one of our latest processors, is out there powering Lumia processors. And even today, we've actually just recently we introduced the 805 with feature level 11.2 in hardware. So we are right there with Microsoft. And going forward, we want to be there with Microsoft. We've been working with them on DX12. And from our perspective, it's a little different, but we see huge value as well. First, power. Everything I do is about power. I measure milliwatts, sorry, not 10 watts, but milliwatts and microamps. And when I hear things like, let's reduce the draw call overhead, let's improve state overhead, let's reduce CPU overhead, that is music to my ears from a power standpoint. That means I can give you longer game time on your battery. It means potentially longer days of use in a lot of use cases as well. It's a great and wonderful thing. Obviously, we love performance as well. We want to get good and great gaming experiences on tablets and on phones. So obviously, reducing overheads, like you've heard a few times now, will improve that performance when required. At the same time, the multiprocessor aspect and the multi-threading improvements that are being done for DX12 are going to be great in the mobile space because we have a lot of cores as well, and utilizing them properly has always been a challenge. And And while I would love to be running always at 3-4 gigahertz, it's a little harder in the mobile platform. So multiprocessing will be very helpful. Plus, feature level 12 itself, we've illustrated a few of the features, but a lot of them are going to translate to better performance and or visuals that just couldn't be done before. Finally, one thing that's exciting for us is both the scalability and portability. On scalability, we ship from within the smartphone business, very low tier to very high tier devices. On every one of those, DX12 addresses and improves the situation. Anytime you reduce the overheads, you're going to get a better user experience for all those different tiers. That's very exciting. Plus, portability. We'll see how the experience goes, but we are super excited about seeing Xbox and PC titles moving into the mobile platform, and DX12 should make that transition much, much easier and should make your lives a lot easier. Overall, we are very excited to be working with Microsoft. It's been a good working relationship, and it's been a long 10-year working relationship, and we're very excited about working and bringing DX12 to the mobile platforms. Thanks.
Thank you so much, Eric. It is humbling to see what an amazing industry support we have around our nascent new API. In fact, I thought it would be cool to invite all our IHV leaders up on stage for a show of industry support together. Come on up. Let's take a quick picture, getting all of these guys on stage together. Awesome. Let's see if we can cram all of this. Wow. So, what does this all add up to? As you just saw, 100% of new desktop GPUs are going to be DX12 capable. We believe 80% of all new gamer PCs selling today are going to be DX12 capable. And with these trends, we think by the time we ship, 50% of all machines out there for PC gamers will be DX12 capable. Also, 100% of all Xbox Ones will be DX12 capable. And before we ship, our mobile partners will be shipping DX12 capable GPUs. So with all that, I'm sure you guys are wondering, when will we ship? So we are going to be targeting holiday 2015 games. We will make sure that our platform is available with plenty of time for all of our partners and developers to be able to ship awesome holiday 2015 titles using DirectX 12. We're going to have a preview release coming later this year. And for those of you who can't wait that long, I'll talk about an early access program that you could probably sign up for. So to recap, we are at a beginning of a completely new era in high-performance graphics. This has been made possible by an industry-wide collaboration to bring console-like efficiency to a broad range of hardware and platforms, to the PCs, Xbox, phones, and tablets, with broad support of different GPUs. So the question is, are you ready for it? So to follow, you can find out what's going on more by following us on our Twitter handle. There's a blog that will have more information. Also, today, there's going to be a series of talks from us, from our partners, that will go more into the details of DirectX 12 and Direct3D 12. And so I invite you all to go attend these sessions. You'll get a lot more information on them. And with that, I wanted to see if anybody had any questions. Thank you.
I was just wondering, since you mentioned that DirectX 12 would be coming to all Microsoft platforms, if you have any intention of supporting Windows XP.
So the question was, are we going to support Windows XP? We have end-of-life Windows XP, and so we're not planning to do any more updates to that operating system.
Fair enough.
My question is the same. Do you support Windows 7?
So the next question is, will we support Windows 7? I suspect more than a few of you are thinking about that. So we understand your desire to get DirectX 12 on the broader set of hardware. We won't be announcing anything today, but stay tuned. Next.
I was just wondering what kind of support DirectX 12 gives you for multi-GPU, particularly like different GPUs. So, you know, every PC's got an Intel GPU in it these days, and it might have a discrete one as well. And there's some pretty unique things you can do with, you know, an on-chip GPU. What does DirectX 12 give us there?
Right. So there's some features that we're working on exactly targeted to that problem. We aren't talking about it today, but we have further disclosures planned in future that'll go over the details of how we will make it really awesome to explicitly target all the GPUs you have on a given system. Anything else? Cool. Thank you so much for coming, and you'll be hearing more from us soon.